The CPU operations themselves can't do any useful work. For them to do some work, you need to provide them with data. Now, for example, our add operation needed two values. Similarly, load operation will need a destination address and a source address so that it can copy the data from source to the destination. A jump instruction will need one value, which is the destination or where to jump. A comparison instruction will need two values to be compared and set the status accordingly. So likewise, every instruction except for special operations like NOP, which does not do anything, will always require some data values or some parameters to be provided with the instructions telling on what the operation need to be carried out. Therefore, typically an instruction will have two parts. Its composition will have two parts. The first part is called the opcode or the operation code. It's a coded value which tells what that instruction is supposed to do. For example, whether it's a load instruction, whether it's a compare instruction, whether it's an add instruction, etc. Then it will be followed by one or more operands. Operands are either the value that the instruction will need to execute or an address of a value which tells where the data value can be found. For example, an operand may present as a memory address which the CPU can use to locate and load the data item in that particular memory location. So, an instruction will always have two parts, an opcode part and a one or more operands. Except in special cases like the no operation instruction, which does not need any operands. It only has the opcode. The number of operands that are present in the instruction will also vary from one instruction to another. Most instructions will have two operands. Some instructions like the jump instruction may only have one operand so that it specifies where to jump. It doesn't need another value to compare or anything like that. It is also important to note that even though we identify these instructions by a name, in reality, they are simply coded values. Every instruction has a binary value, a binary number or a pattern of ones and zeros, which is represented in the CPU circuit as a combinations of high and low voltages. But for us, it is very difficult to deal with those ones and zero patterns. So therefore, we assign them with names for our convenience. But when they are executed in the computer, they are represented by those binary codes. In the same way, we use binary codes to represent letters in our alphabet. For example, either as Unicode letters or either as ASCII characters. So likewise, everything inside the computer is a binary pattern. So depending on how we interpret them, it could be an instruction, or it could be a numerical value, or it could be another code representing a letter in the alphabet.